this video we are going to cover flashing firmware to the ESP8266 using Linux. We will be using Ubuntu 15.04, but the process should be similar in other Linux flavors. Also, we're going to be using the ESP8266-01, but other boards should be a similar process as well. You will need to have a ESP8266 board, a USB to serial adapter, and a way to connect the board and the USB to serial adapter together. I do expect to follow this video with several other videos, including one showing the difference in the various ESP8266 boards, as well as a video on different ways to connect these boards, including both methods using a breadboard as well as methods without a breadboard. Almost all of these boards have non-breadboard friendly pinouts, so I've devised a few ways that make connecting them a little bit easier. So please subscribe to my channel and look for those videos to show up in the near future. Okay, so the first thing we're going to do is we're going to prepare the software to work with the ESP8266 firmware flashing. The software that we will be using to flash the firmware to the ESP8266 is called esptool. It is a set of Python scripts that allow it to allow the firmware to be flashed to the ESP8266 from your terminal in Linux. So we're going to go to a web browser and search for esptool. The first result here should be the Mad Inventor /esptool on GitHub. That's the one we're going to grab today. Personally, I prefer to use Git for these types of things. If you're uncomfortable with Git, feel free to download a zip file using the download button right here. Again, for myself, I am going to use Git. I'm going to copy the Git clone URL. I'm going to open up a terminal window, and I'm going to switch to my Git repos directory and do a Git clone, paste in the URL, and I should have it all there. So that will have cloned into esptool, and if we take a look at what's in that directory, you'll see the esptool.py. That's the Python script that we're going to use to flash the firmware. Before we can get going with that, though, there's a couple more things we need to do. First thing we need to do is we need to take a look at the dependencies for esptool. And on the GitHub page here, we can see that there is one dependency, and that is the PySerial package. So what we're going to do is we're going to go back to the terminal window again, and we're just going to issue a apt get install Python serial. If it already exists, it won't hurt. As it does on my system, we'll see that Python serial is already the newest version, so it did nothing. If you did not have it installed, it would have gone ahead and installed the Python serial package. So at this point, I think we're all set with the esptool. We'll be needing to move on to getting some firmware binary files to flash to the ESP. So we're going to move on to that next. So the firmwares that I am most interested in for the ESP are the Node MCU firmware and the firmware that allows use of AT command set. First thing we're going to look for is the Node MCU firmware, and if we go to Google and type in Node MCU firmware releases, the top item here in the Google search is Node MCU firmware releases, and we're going to click on that, and here You can see we've got the source code, but we're after the binary files today. And you can see there's two different versions. There's a float version and an integer version. Um, the float version allows floating point calculations, whereas the integer version does not. The integer version will use a little bit less memory, so if you don't need floating point calculations in your code, the integer version may be best. So I'm going to download the float version, and that's because I just don't really know what I'm going to be doing yet. Down the road I can optimize if I need to. So that will have downloaded the firmware to my default download directory. So I can see the Node MCU firmware right there. We'll come back to that a little later. The other firmware that I'm interested in is the firmware that allows use of the AT command set with the ESP8266. And it's a little convoluted to get to. So what I'm going to recommend is Google for AI Thinker firmware. And we're going to look for the result that includes Electro Dragon. The Electro Dragon site has a pretty quick path to get to the Google Drive where these firmware files live. I can see a couple different versions here. Old, we don't want old. We've got the new version, which seems to have a lower version number than this one. So I'm going to go with the 0.952, and I'm going to go over here to the firmware and download that. Hit save, and that also should end up in my downloads directory. Okay, so now we have our firmware, and we also have the ESP tool. One thing that we'll want to do to prepare for the future operations here is we're going to take both these firmwares and copy those into the ESP tool directory. It will make the command line a little less complex when we go to use the ESP tool. Okay, so now that we've done that, we're going to move into making the electrical connections to the ESP board and the USB to serial adapter. So we're going to take a look at that now. Okay, so now we are going to talk about connecting up the ESP8266 to the USB to serial adapter so that we can flash new firmware. Taking a look at the image on your screen right now, we're taking a look at the ESP8266 as if we were looking at the top side of the board. The way you can tell for sure if you're looking at the right side of the board is if you can see this trace that makes up the antenna for the device, as shown in yellow on your screen. Arrange your board so that that's to the left hand side and you're looking at it, and then we have these two rows of pins on the right hand side. Starting on the right hand side set of pins, from the bottom going up, we've got the transmit pin, the chip power down or chip enable as it's sometimes called, the reset pin, the 3.3 volts positive pin. Then moving over to the left hand row, starting from the top down, we have the receive pin, GPIO 0, the GPIO 2, and on the bottom ground. So the way these get connected for flashing the firmware is the same as normal operation, with the exception of the fact that when flashing firmware we're going to drive GPIO 0 low, or pulling it to ground. So for this setup we're going to have that pulled to ground. The other pins are all the same as they would be under normal operation. The transmit pin is going to go to the receive of the USB to serial adapter. The chip power down is going to be pulled high to 3.3 volts. Reset is also going to be pulled high to 3.3 volts, and the VCC is going to be connected to 3.3 volts positive as well. Receive is going to go to the transmit of the USB to serial adapter. GPIO 0, we're going to pull to ground. GPIO 2, we're going to pull to 3.3 volts, and ground is going to go to ground as well. Taking a look at the breadboard I have set up here, you can see my ESP8266 chip in the center here. And you can also see this little adapter that I made up to allow the pins to span the center section of the breadboard. As I mentioned earlier, I expect to do a follow-on video that shows different ways of connecting the ESP8266s, both using breadboards and some other methods as well. So please subscribe to my channel and look for that to come up in the near future. So in this case, I've got from the lower left-hand pin right here, this is going to go to the receive pin on the USB to serial. Then the other three on the bottom row all go to the positive rail 3.3 volts on my breadboard. On the back side, we've got all the way over on the back right here, that is going to the transmit pin on the USB to serial adapter. And then we refer back to our little pinout diagram here. GPIO 0 is going to be pulled to ground. I have the connector off right now, off the breadboard. This will be put to the negative rail on my breadboard when we're ready to flash. Then we have GPIO 2 that is pulled to 3.3 volts. That's this little red wire here coming out from behind the chip. And lastly, ground is pulled to the negative rail of my breadboard. So that's pretty much it for connecting it up. You have USB cable, of course, going to the PC. The other thing worth mentioning is that the ESP8266 is a 3.3 volt device, so you need a 3.3 volt power source. I'm just using a little USB breadboard power adapter here, and it's got a voltage regulation circuit, so I can choose with this jumper either 5 or 3.3 volts. So that's handy for these projects, and it's got an on-off switch up here, and it also can be plugged into a power brick with a little barrel connector here, so that's a nice little device to have. So again, using a little adapter here, we're able to set this up on the breadboard and connect it up and get it ready to flash new firmware. So next we're going to get into actually getting into the software and the command line options for flashing new firmware. Okay, so we are now almost ready to flash new firmware to the ESP8266. Before we do, we are going to make a few last sanity checks, and the first of which is to make sure that our system recognizes the USB to serial adapter. To do that, we're going to first plug the USB to serial adapter in to the USB port on the PC. Then we're going to run the dmessage command and pipe that through tail so we only get the last 10 lines of the return. And on my system, I get back the last line, FTDI USB serial device converter, now attached to TTY USB 0. So that's a good sign. Your adapter may be slightly different, so this text might be something a little different. But if you see something that indicates a USB to serial device has been connected, you're in good shape. Make a note of this TTY USB 0 on my system. On your system, it might have a little bit different number. So make note of that because we will use that in the future here. So the next thing that we're going to do is to apply power to the ESP8266 board. When I do, I get a quick flash of the blue LED, and then the red LED stays on. If you have the LED lit, you're in good shape. If not, you may want to go back and review the section on hooking up the electrical connections, and then come back to jump into the next section dealing with the ESP tool to flash our new firmware. So the next thing that I am going to do is just check real quick to make sure that I am in the right directory to work with ESP tool. And I can see here that I do have ESP tool in the directory, and I also have the firmware that we downloaded right in the directory, which will make the command line a little bit easier. So next thing I'm going to show you quickly is that ESP tool actually has a built-in help menu. So if you type in esptool.py --help, you will see some information on usage of this tool. What we're going to be using is the right flash, and we're going to also use the optional argument to indicate which port we are connected to. So let's get to it. Our command is going to be esptool.py-p dev tty usb0 and right flash. We're going to give it the starting address for the flash to be written to, which is 0x00000, and then we're going to tell it which firmware, and we're going to use the node MCU, and that was the float version that we used. If everything is hooked up and goes well, we should see some results here. We're connecting. It's going ahead and erasing the flash. This does take a moment, so we may go ahead and fast forward through this. And leaving, so it exited without an error message. I think we're probably in pretty good shape. A good way to test to see if everything worked is to open up ESPlorer, and we can use this to send some node MCU or Lua commands to the board and see if it responds. Before we can do that, though, we're going to have to power down the ESP8266 and disconnect the wire that is grounding GPIO 0. Power it back up, then it will be ready to accept commands. With GPIO 0 grounded, it was in the mode to accept new firmware, so it will not accept commands while that GPIO is grounded on startup. So I've disconnected my GPIO 0 from ground. I've powered down and back up again. I'm going to see dev tty USB 0 up here. If I saw something else, I'd want to switch to the right port and hit open. So we've got some good results here. Connecting with MCU, got an answer. Node MCU firmware detected, and it returns the current heap. So we can go down here, send chip info, chip ID, flash ID, heap, and it seems to be responding well. So I think that we have been successful in flashing the Node MCU firmware. Okay, so now that we've successfully flashed the Node MCU firmware to the ESP8266 and tested it with Explorer, I wanted to circle back and show how easy it is to flash alternate firmware once you have the setup. So in order to do this, the first thing that you're going to need to do is power down the ESP board and reconnect GPIO 0 to ground. Once you've done this, you can power the ESP board back up and go to your terminal, and we're going to use the ESP tool once again, and we're going to tell it which port we're using. In my case, that's still dev tty USB 0. We're going to let it know we want to write flash, and starting at 0x0000, and the firmware that we're going to use, which is v0.9.5.2 atfirmware.bin. So now when I hit return, if we have a little bit of luck, it's going to complain that it failed to connect. So what I'm going to do is just power the board back down and power it back up in case there was some issues with it reinitializing. So now that I've done that, I'm going to send the command once again. Okay, it connected this time, erasing the flash, and now it's writing the new flash to the board. Once it's finished with that, we're going to open up Explorer once again and see if we can send some AT commands to the board. Okay, now that we've successfully attempted to flash the AT firmware on here, we're going to go to Explorer and take a look at sending some commands over to the board to make sure everything worked as expected. So we're going to first take a look at the port here. The USB 0 is the port that we've been using all along, so that looks good. One thing I'll call your attention to is the baud rate. There was a change over the Node MCU firmware that we were using, which was at 9600 baud. This AT firmware is at 115/200. So if you are having some trouble connecting to a board after flashing a specific firmware, take a look at what the default baud rate is for that firmware. And if you can't find that published, try a couple different ones. 9600 and 115/200 are the common ones that I've seen. So I'm going to go ahead and hit open here. So this looks good. Connecting communication with MCU, got answer. Auto detect firmware. It's got AT-based firmware was detected. It's giving the version and the SDK version and an OK. So that looks good. And then over here I can send some AT commands. So they all appear to be successful at this point. So I would say that that this is a success. Just to show you real quickly, if because this has happened to me before, if I had chosen the wrong baud rate, if I went in at 9600 and tried to open it, it would have an answer, but when it tried to auto detect the firmware, it's not giving you the answer you would expect to see. So that was because of the baud rate being incorrect. If I switch back to the proper baud rate, it should behave like it did initially. So that's looking pretty good. Okay, so it is now time to review what we have learned in this video. So the first thing that we looked at was where to get the esptool.py and how to verify that its dependencies were met. From there, we learned where to find two different types of firmware, the Node MCU firmware as well as the AT command set firmware. We also downloaded those two firmwares to the esptool directory for use later on. Next, we learned how to make the electrical connections to the ESP board. Then we went ahead and used esptool to flash the first firmware to the board, after which we used Explorer to connect to the board and make sure that the firmware was operating properly. Okay, well, we have now reached the end of our video. If you have any feedback for me, please leave it in the comments section, as it will help me to make better videos in the future. Please also subscribe to my channel, and I will be inspired to continue to make helpful videos for the ESP8266 and beyond. Thank you for watching.